Hi, good day everyone. My name is Angel Castron Perez. I believe everyone knows what is energy, right? But if it's not, I will be tackling it down. Okay, when we say energy, it is the ability to do work, and it is a fundamental concept in physics, exists in various forms. Also, it cannot be created or destroyed. So when we say it cannot be created or destroyed, this means that energy is always there and it can't just appear or disappear. Instead, it can change from one type to another. For example, a light bulb converts electrical energy into light and heat energy. Also, a car engine converts chemical energy from gasoline into kinetic energy. So the total amount of energy stays the same, but it changes forms. Got it? Did you know, guys, that there are four types of energy? Firstly, we have thermal energy. Okay, thermal energy is the energy of heat, which is transfer of energy from one body to another due to a temperature. For example, a boiling water. Thermal energy is transferred from the stove to the water. Second example, warming up on a cold day. Thermal energy from the sun or a heater warms you up. Also, guys, internal energy is a type of thermal energy, which is the total energy of an object or system due to the motion of its particles, atoms, or molecules, and the potential energy associated with the vibrations and the rotations of those particles. The second one is electrical energy. It can be converted to thermal energy using a heater. The third one is the chemical energy, the energy stored in the bonds of atoms and molecules, which can be released through chemical reactions. For example, in food, chemical energy is stored in the molecules of food, which is released when we digest it. Or in batteries, chemical energy is stored in the chemicals inside a battery, which is converted to electrical energy. Last one is kinetic energy, the energy of motion which an object possesses when it is moving. For example, moving vehicles, a car, bike, or train in motion possesses kinetic energy. We also have wind and water. Moving air or water can possess kinetic energy which can be harnessed using wind or turbines. Okay, so when we say work transfer, it is a work which a specific type of energy is transferred. It occurs when a force causes displacement of an object. So when force is applied, external influence. When energy transfer results from interaction. When displacement occurs, there is change in position. So guys, here's a simple work formula. So work equals force times distance, or W equals F times distance, wherein W is the work done, which is measured in joules, or J. F is the force applied, measured in newtons, or N. D is the distance over which the force is applied, measured in meters. For example, let's say you're pushing a box with a force of 10 Newton over a distance of 5 meters. How much work do you do? So we need to use the work formula. So W equals F times D. So W equals 10 Newton times 5 meters is equals to 50 joules. So you do 50 joules of work pushing the box. And also, guys, we have here types of work. First one is positive work. When a force applied to an object helps it move in the same direction as the force, the work done is positive. Think of it like pushing a box forward. You're applying a force in the direction of motion, so you're doing a positive work. When we say negative work, when a force applied to an object opposes its motion, the work is done negative. For example, when you're trying to stop a moving box by applying a force opposite to its direction, you're doing a negative work. Lastly, we have here zero work. When the force applied to an object doesn't cause it to move, or if the force is perpendicular to the direction of motion, the work done is zero. Imagine holding a heavy bag without moving it. You're applying a force, but since there's no displacement, the work done is zero. Okay? Okay guys, to sum up, energy is capacity, which is to cause, change, or do work. Work is transfer, meaning energy via force and displacement. Lastly, formula is the key, which is don't forget W equals F times D for calculation. That's it for today, guys, and I will give the table to my partner, which is Ken, for the next reporter. Thank you for listening. Have a great day.
Good morning everyone, this is Ken Jasperview, and today I am going to report the chapter 2, Energy and Energy Transfer. Under this chapter, I am going to discuss the expressions for displacement, work transfer, and power. First, let us define the work done. Work done is on object is defined as the energy transferred when a force causes the object to move over distance. W can be represented as W is equals to F times D times cosine theta, where W is work done in joules, F stands for magnitude of the applied force in Newton, D stands for displacement of the object in meters, theta stands for angle between the force and displacement direction. For example, a person pushes a box with force of 50 north at an angle 30 degrees to the horizontal. The box moves 10 meters along the floor. How much is done by the person on box? Let us solve the problem. The given are: F or magnitude of applied force is 50 north, D or displacement of the object is 10 meters, theta or the angle between the force and displacement is 30 degrees. Let us plug the values. Work done is equals to 50 times 10 cosine 30 degrees. We know that cosine 30 degrees is 0.866. Let's put them together. Work done is equals to 50 times 10 times 0.866 is equals to 500 times 0.866 is 433. The work done by the person is approximately 433 joules. So the last topic in this chapter is power. So what is power? Power is defined as the rate at which work is done or energy is transferred over time. It quantifies how quickly work can be performed and is mathematically expressed as P is equals to WP, where P stands for power in watts, W stands for work done in joules, and T stands for time in seconds. Let's have an example. A steam engine performs 3000 joules of work in 60 seconds while moving a piston. Calculate the power output of the engine. The given are: W or work done is 3000 joules and T or time taken is 60 seconds. Let's solve. Power is equals to work done, which is 3000 joules, over time taken is 60 seconds. So 3000 joules divided by 60 seconds is 50 watts. So the power output of the engine is 50 watts. In conclusion, displacement, work transfer, and power illustrate how energy moves and changes form within and between thermodynamic systems. Understanding this interaction is crucial for analyzing engines, refrigerators, and real-world thermodynamic processes, and for applying the laws of thermodynamics effectively in engineering and physical sciences.